development of the Open University of Sri Lanka is on the impact analysis of salinity barrier across Nilwala River Basin, which had a recent flood event at the end of the last year. The resource person for today's talk would be Engineer ADS Iresh. I would like to give a brief introduction on our resource person. Our esteemed resource person for today's environmental talk on impact of analysis of the salinity barrier across Nilwala River is an irrigation engineer with over 12 years of dedicated experience in engineering within the irrigation domain and stands as a seasoned chief engineer currently leading the hydrology and disaster management division at the Irrigation Department. Holding a master's degree in hydrology, specialized in surface water and hydrology from the prestigious Indian Institute of Technology, and pursuing his PhD in climate change and hydrology at the Open University of Sri Lanka. Engineer Iresh brings a wealth of knowledge and expertise to our discussion. His academic prowess is complemented by a rich portfolio of publications, including studies on flood frequency analysis, development of hydrological models, and drought studies within various river basins of Sri Lanka. Notably, his research contributions have been recognized and published in reputable journals and proceedings of esteemed conferences. As a chartered engineer of Institute of Engineers Sri Lanka and a member of International Commission of Large Dams, he possesses a comprehensive understanding of water resource management, flood mitigation, and environment impact assessment. His expertise makes him a valuable resource in unrailing the complexities around the impact analysis of salinity barrier across the Nilwala River, a critical issue at the intersection of hydrology, ecology, and environmental conservation. I'm privileged to have Engineer Iresh share his insights and expertise with us today. Over to you, sir.
Okay, thank you all. Thank you, Imogen, for the introduction. I think you can hear me. Is that?
Yes, sir, you're audible.
Yeah, okay. Okay, good afternoon to everyone. First of all, I like to thank the Association for the Advancement of Science for organizing such a webinar to discuss a very important topic of the time and invite me as a resource person for the webinar. And today the important topic is impact analysis of salinity barrier across Nilwala River. And I am Engineer ADS Iresh, Chief Engineer from the Hydrology and Disaster Management Division of the Irrigation Department. So starting with a very brief introduction to the topic. As you all know, this is a very interesting and timely and needed topic. I must say that there are two institutions that analyze the impact of salinity barrier for floods, and both these institutions have opposite is the study that was conducted in Irrigation Department. So you may all know that it's situated in down south of the country, mostly belongs to the wet zone of Sri Lanka, and the total area is around 1,000 square kilometers. The annual average discharge to the sea is approximately about 1,400 MCA. So this is a wide basin with a comparatively large low-lying area. And this basin includes large floodplain, mostly consisting paddy fields, as you can see in the figure, the left side figure. So the green color area, mostly the paddy field and the low-lying areas. So there is a flood protection scheme is implemented in 80s, but not completed, and it is halfway through. So if I give a brief introduction about a river network and the water resources of Nilwala River. So there are few water resource developments. Those are Lane Bitueva, Lane Batueva, Kirama Vava, Allevava, Denagama Vava, Kakuna Duravava, and there are some more. So actually, the basin water, the river water is also used for drinking water supply as well. So there are many water resource development proposed to divert water to the adjacent basins like Hambantota district. But unfortunately, due to many reasons, those proposals have been not implemented up to now. So the Nilwala River has a flood protection schemes which was designed 1980s, and there was a, at the design stage there was three stages, and the scheme is planned to protect up to 10-year return period flood. But however, due to the insurgency of during that time, that project has not been totally completed, but it was completed halfway and uh, completed halfway through. So you can see the basin, the river network, how it's very, and actually where the salinity barrier is located is the river, the red dot show what is the salinity barrier location is. So the salinity barrier was constructed during the time of 2019 to 2022 period. So it was constructed in the large and wide floodplain of the downstream of river. The floodplain is mostly consisted of paddy fields, which is around 12,000 acres. A considerable portion of Mathura town is inside the floodplains, and a large number of villages are within the floodplain. So salinity barrier has been constructed in the vicinity of Mathura city, as you can see in this Google image. So the red color circle where is the salinity barrier, and the Mathura township you can see in this Google image. So due to the social impact and with that the political influences came to the irrigation department, then we have considered to carry out a systematic analysis. So this is the schematic diagram of the analysis, uh, starting with the public complaints. Sorry for that. Starting with the public complaints, and we analyze the complaints before and after, and compare loss and damages before and after, and compare the behavior of floods before and after, and compare the rainfall before and after, and the in the final stage we did the flood modeling considering two scenarios basically before and after. For that we have used HECRA's hydrodynamic model. So this is the schematic diagram which we have used for our analysis. So come to the comparison of public complaints and opinions before and after construction. So there were public complaints, especially from farmers, even before. But unfortunately, after the construction of salinity barrier, these public complaints have been increased drastically. So considerable public protests have been started by various social groups. So you may have experienced that through social media as well as through media. So those events they have published, and we can see that we had seen that events. In response of public opinions, the structure have caused for aggravating floods. So that is their opinion. They are saying that this structure is a problematic structure which cause extra flood for Nilwala basin. Then compare the loss and damage caused by floods before and after construction. As per the official reports, more than 6,500 acres of paddy cultivation completely lost in 2023 flood. Jala flood. This is the largest ever damage extent reported in the Nilwala scheme. I must say that this event is not the largest event, even though it is not the largest event. So we have came with this much of large uh, paddy field damage. Then the cultivation performance data shows that area of cultivation gradually reduced till 2019. This is according to the Water Management Division of the Irrigation Department data. So the cultivation performance data increased up to 2019, but after the 2019 up to now, it's gradually decreasing. So obstruction to transport owing to the inundation of roads in 2023 flood is a huge and incomparable with previous floods. So that's what we have observed through this comparison of loss damage. Coming to the flood behavior, by analyzing the flood hydrograph, you can see in this graph. Uh, this is the graph flood hydrographs of previous floods, starting with 2012 flood to up to 2023 flood. So you can see that these lines, how these lines are. You can see the major flood events at this is for the Panadugama hydromet station flood hydrographs. 2012 flood is the highest flood, and even 2023 flood, the previous flood is not that much up to that much level. So even though it is not that much level, that was recorded as the mostly impacted flood event. So this and using this flood hydrograph, we have analyzed how this flood hydrographs recession limb is varying with the previous condition and with the present after the salinity barrier condition. So this is for Talgahagoda water level gauging station data. Using this data, we have developed the hydrograph for each and every flood events recorded. So you can see the green lines are for the flood events which occur during and after construction of salinity barrier, and the blue lines are before the salinity barrier. By doing this analysis, what we are trying to understand, what we are trying to analyze is how the hydrograph is changing and what is the difference between the recession part of the hydrograph, because we have observed that before the salinity barrier and after the salinity barrier, in both in these two hydrometric stations, the hydrographs give difference in the recession limb, not in the rising limb. So, but looking on that, we have analyzed the recession time of the hydrograph and the peak and all. Then we have come across what is the difference of those hydrographs, and we found that the average recession angle before the salinity barrier is around 1.9 degrees, but after the salinity barrier it is 1.27 for Panadugama river gauge. For Talgahagoda it is around 0.63 degrees for before the salinity barrier, and after it is 0.5. So by looking on that, we can see that analyzing various flood events, the recession limb is extended value. So the the time period of reducing the flood has been extended. So that is a major finding. So it shows that there is a impact. Of course, there is an impact of salinity barrier when we compare those flood hydrographs before and after scenarios of both the river gauges. So this is a basic view of the salinity barrier which was constructed, and this is how it was built. So you can see the structural view and the physical view from the plane and the sectional views. As you can see, the both the both side of the banks, they have constructed some kind of a sheet files, and the levels are very much closer to the zero point 0.6 and 0.7 MSL meter level, and only the remaining portion is allowed to pass the water. So there are 5 gates with the sill is uh, around minus 2.5, whereas before the construction the river bed level is around minus 4.2, and after the construction they have kept the sea level at minus 2.5. So that means that uh, the the cross section area has been blocked. About 40% of the cross sectional area is blocked. So that is it's a kind of a arguing problem. Is it is it is sufficient to pass all the water to that section? Because previously, before the construction, it is this the bed level is at around minus 4.2, and it's now it is at minus 2.5. So problematic, and so this gives us we have to do a further analysis to find so what is the impact really, is it happening or not. So with that we have carried out our research. So for that we have used the computer technology of modeling, the flood modeling using 2D and 1D modeling, HECRAS model we have used, and this is the schematic diagram which we have used to model the basin. So upstream inflow and the downstream for the boundary condition we have used upstream boundary condition as inflow at Peterbedder, and downstream because Peterbedder, of course, irrigation department, we maintain a river gauge which is very much accurate, and timely we do calibration of that river gauge, and we use to analyze how much water is passing through that river gauge. So those data we have with us, and using those data, and for the downstream we have used 0.4 meter MSL sea level, because very recent CRIP project, the project has developed many scenarios, and their final report, they conclude that with the climate change impact, there will be a minus 4 meter MSL level, sea level will be experiencing in near future. So we are taking those boundary condition into the model. So all the bridges and the structures along the main river was considered and included to the model. So the lateral inflow was given to the model using the HEC-HMS model, which was calibrated using the Peterbedder data, and the HEC-HMS model parameters have been used to give the lateral inflow from the subbasins to the main river at all tributaries, and those inflows have been used for the 2D hydrodynamic models as well as for the 1D model. So the model was calibrated using the Talgagoda river gauge So the calibration and validation is a little bit difficult, as you know that Talgahagoda river gauge is kind of a tidal gauge. So calibrating a tidal gauge is it's a very much difficult thing. With all those difficulties, we were able to do some kind of a calibration using the Talgahagoda river gauge data. Actually, we cannot create a rating curve for the Talgahagoda river gauge because of this tidal impact, and we are not maintaining a rating curve. So we only have the river water levels. So considering those river water levels data, we calibrated the model and also validate model, and we compared with then we calibrate the model before the period before the salinity barrier, and use for the uh, simulation after the salinity barrier. So included all the bridges and the structures along the main river. So this is how uh, the schematic diagram of model development. So this is a screenshot of 2D hydrodynamic model last screenshot. You can see we have included many boundary conditions, and starting with Peter river gauge to all the and we considered the flood banks. So we developed the 2D mesh area in between the flood banks and the river along to the sea. So this is how the model setup was developed. And so in the largest scale view, you can see how this model was developed, and where are the areas cover the 2D uh, inundation, 2D area of the model. And after calibration and validation, we simulated the model for the by including the salinity barrier and see the variation. You can see this is a screenshot of here, which is now constructed. Before the construction, you can see the streamlines. It's going straight away. No any other movement of the streamline. So it's very clear path is there to pass out the water through that section. So this is output of screenshot of simulation before the salinity barrier. So this is a screenshot after the salinity barrier. You can see after the salinity barrier. So the streamlines have some obstacles, then the streamlines have some kind of a deviation, and uh, not not the similar case in the case of before the salinity barrier event. So this is how the streamlines are varying. So we can see this is for both. This is for the similar kind of flood event. So you can see even the flood inundation, even in the at the cross section of salinity barrier, it's very much than the before case. And uh, doing these things with many scenarios, I am not going to present all those sort of scenarios and what we have included. And finally, whatever we do, we whatever the scenario we include, even we have tried for return period floods. So even for return period or whatever the experience flood we include for simulation, what we get, it's like this. It's on an average, the impact is around 0.3 to 0.4 meter rise for salinity barrier case scenario than the without salinity barrier. So in our model, what we have experienced is that so there is some impact as far as the basin is low lying basin, and the floodplains are really low lying areas. So zero point 0.3, that means 1 foot is very much it will give a bigger extent of flooding as far as the area is very much flat. So this is what we got, that there is an impact of that salinity barrier. It's around 0.3 to 0.4 meter rise. So that is the final finding of our research. So that's all for me today, and thank you for listening. And I'm very much happy to share whatever we have experienced and whatever the things you have any problems. So I'm happy to provide answer for that. Okay, thank you.
Thank you very much, sir. Audience, if you have any questions to raise, the floor is open now.
Himanujan, can I ask a question?
Yeah, sure, sir. Go on.
Yeah. Thank you, Engineer Iresh, for your presentation, and it's really, really interesting. So, as a civil engineer, so I got this kind of question, but it's in another dimension. But so, as you know, in the case of the due to the past coup day terrorist attack, so you remember that someone went to court and make a case, a human right case, and as a result, several government officers have to pay from their own money for those victims, right? So based on that information and evidence, I would like to know, like, in this case, like in the Nilwala barrier thing, so if someone go and make a case against the engineers, so is there any legal risk for engineers that we could pay from our own money? Because why I'm asking this thing is, in your presentation also you mentioned that there were difficulties in validation because of our data policy in our country, because I really don't know how much budget is allocated from Irrigation Department or the ministry to collect data and record this data and preserve this data and those kind of things. So I mean, if we have sufficient data, yes, of course the validation process is quite easy, but the issue is we don't have such data, historical data and other things. So so my question is really that, like, so is there a policy to data collection and these kind of things in order to to safeguard us as engineers? So that's my question. I don't know whether you got my question is.
Yeah, I got your question, and it's giving that answer for that is really again a question. Okay, anyhow, I will give some kind of answer regarding the data. Actually, irrigation department, we have a lot of data. Even we, if somebody request, we are volunteer to give the data. Of course, we have to go through our rules and regulations. For government institutions, with the approval of secretary, uh, may not need to pay. If somebody outside may need to pay, that's how the policies are. But actually, data is there. What I said, that regarding the data, the hydrodynamic model calibration is difficult using a tidal gauge. So that's a problematic, and it's a tedious task. So
Okay.
that's
Thank
how
you. Thank you.
it's and of course somebody then I said in the beginning also, ourselves and another institution, I don't want to mention about the name of that institution. They have also done a research and done a nice research. Then it's a good thing. Then, but they found it's the results are totally different than us. We have no argument about it. That because that is their thing, and they have used a different model. As far as they have not given us the model setup and all, we cannot comment on that. We have only got the report. So by looking at the report, if they say this is there no impact, so that is there. But we have some comments, but it's a kind of a arguing position now. So what we are now actually in the ministry also, this problem is uh, discussing, and what we are planning to give another consultancy to a third party, because both the institutions are very much actually irrigation department. As irrigation department, we are responsible for all these rivers and all these floods and all, so we have the responsibility. The main stakeholder is us, but for the other side, actually the water board, they constructed the salinity barrier, and uh, they have consulted the team, and the results, their team result is different than us, the opposite of that. So with that, so what we thought, we will go for another consultancy to understand how it's, because both the parties are the two teams which involved in two ends. So better go for a third party and see what is the difference and what is the similarities the third party will get. So if something has happened, and some, as you asked, I think that we have to face if with the results of the third party. Then if somebody goes to court, it will be
Okay, thank you very much for your elaborated answer. Thank you, thank you very much. Yeah, over to you, Himanujan.
So there are a few more questions from the audience. There's a question: is there a method to obtain the river gauging station data for further studies for scholars?
Yes, we in irrigation department, I don't think in government sector any other department give free data. Of course, in irrigation, you can have the free data of one basin, that is river gauging station data for a one basin, to use for the scholars, for the researchers, for master, it can be a master or PhD or undergraduate research. For that, we have a guideline for that, and it is in our website, irrigation department website. So you can follow the guidelines, and there are some bonds to sign. So you can request through your dean with the mentioning what is the required data very specifically, and you can request it, and we have a bond. You have to sign it with your supervisor. So at the end of the day, what we need your research thesis to the department, and that will be helpful for the country. So that is the main idea, and we are giving freely uh, one basin data, which is river gauging data, freely for the scholars and the researchers. That is there. So you can have it. You can follow our guideline.
Thank you, sir. There's another question, and it's about the Nilwala River flood events. And the question is: have you forecasted future flood risk due to the structure, and any mitigation actions regarding that?
Yes, of course. Now the model has been calibrated, and it's there. So future forecasting is not a huge problem. So what we need what we have to do is we have to get the GCM outputs, specifically the rainfall, and downscale it and use for simulation, future simulations, and uh, do to analyze what will be in future. And of course, in this moment also we have given some mitigation actions to reduce the flood. We have proposed for the left side. We in the model also we have checked that we can reduce up to some extent the flood level if we cut open the part of left side, and if we remove those the sheet piles, as I showed you in my presentation. There are sheet piles both sides of the salinity barrier. If we remove those sheet piles, we can reduce up to some extent, but not everything as before construction of salinity barrier, but we can reduce some water level using those mitigations. Of course, that I said, as I said, only need to do the bias correction and use those GCM or RCM data sets, specifically the precipitation, and use for those data for our model to simulate. So that is there, but still not done. But of course, that can be done. Yes. Thank you.
Thank you, sir. Any more questions from the audience? Yeah, hope there are no more questions. And once again, I would like to thank our resource person, Engineer Iresh, spending his valuable information and his time on the recent event and the impact of the salinity barrier in the Nilwala River. And thank you very much for joining us, and hope you all gained a good knowledge in the short time. And thank you very much, sir, for accepting the invitation and spending your time and information with us. Thank you very much.
Thank you. Thank you. Thank you very much.